if you really see, since I said earlier, we know how SQL functions. We know how our cloud is. So I know Azure SQL gives you the best performance of the application, and we optimize it based on the SQL Server functionality, right? If you have any, and Azure SQL is a PaaS offering, as I said, right? So which means all you need to worry about is the application. Data layer is not to be worried about. All the admin activities of the database is taken care by Microsoft, which means backup restore, high availability, disaster recovery. So many things are built in as a service. You just keep choosing what you want, and accordingly we will deploy that thing in the cloud. Next is you start small, so you will not have a large database in the beginning. You will start with a small database, and as your user base grow, and you may want to scale up the database further, right? And as we promise, your data is always secure with Azure SQL, and be it any Microsoft offering, your data is always kept secure, right? So right now, if just to give a number, we are running close to 13 million PaaS databases in our cloud, right? And they are highly reliable, secure. We also have a lot of AI capability built in our ecosystem, which helps running Azure SQL as more resilient on our platform. Now, if we talk about the challenges, what you typically see in the databases, right? The typical challenge is the scaling up, right? When I say scaling up, which means, let's say you are running SQL on a machine which which will have limited capacity in terms of vCore, memory, CPU, and if you think that machine is not sufficient, what you will do next? You have to scale up, or in that case, you will procure a new machine with a larger configuration, and then move the databases there and run the application from there. So scalability is one of the challenge. And once sometime it may happen reverse. You have provisioned a lot of resources, assuming the growth of the application, and it didn't go as planned. And in that situation, you are overspending the money because you have procured a beefy machine, but your application is not using that much of database, so it is underutilized. So scaling up and down, and meeting your business goals and the financial numbers is very important for a database to be performant, right? Next is performance, and everyone knows, like performance is the core of the database. If your database is not performing good, it is not useful for the application. Availability is the next pillar, which always comes to architect's mind, that hey, what if this machine goes down? How will I make my database failing over to somewhere else? How can I make it highly available in case of power failure or whatever happens to the data center or the machine on which SQL is running? And the last piece is, of course, security is the key for all the application layer requirement. You should not have unauthorized access to the data. Even if there's an admin, you should be able to mask the data. So there are a lot of challenges which you will see with the databases, and these challenges are there across like many of the databases, and we everyone solves them differently, right? Now, back in 2019, when we were trying to see, what can be done to solve few of these problems, one of the scaling problem is what we solve by using this new thing. And this is a research paper which was published, and it is available on the public domain. The URL is in the bottom of the screen, and this was called as Socrates. Socrates is an architecture which decouples the compute and the storage of a database, right? And this was presented in SIGMOD, 2019, and this is where it born, right? And this whole architecture was taken as a cloud born architecture, and we came up with this offering called as Azure SQL Database Hyperscale. If you want to dig deeper, you can always look at the white paper. But I'll cover few things about Hyperscale, and when you read the white paper again, it will make sense that hey, what was written is what we implemented in our code. Now, Hyperscale is a brand name, right? Socrates was the name of this architecture. So internally, when we talk within Microsoft, we call it a Socrates sometimes. So Hyperscale is the public domain name. Now you might wonder, when you say hyperscale, the common notion which comes to someone's mind is that, should I use hyperscale database? Does it mean that it is only suiting for the databases which are large in size? If I have, I've interacted with few customers, and when I say, why don't you go with hyperscale, they said, no, our database is like, few gigs, like 100 gigs database. We don't need hyperscale. This is a myth I want to just burst. Hyperscale, if you look at Wikipedia, and this is images from there, Wikipedia says, and that this is the definition from the Wikipedia is, hyperscale doesn't mean large. It means that you can seamlessly add compute, memory, networking, storage to the given set of nodes. And then it is running distributed architecture. So hyperscale is a scalable system running as a distributed architecture. Even though the notion gives a hypersensitive, hyperactive, hyperscale, it is not really true. The name hyperscale does not mean it fits only for the large databases. Yes, we do support 128 up to 128 terabyte of database, but it doesn't mean that it will not work for a small size of database as well. So whenever you start building or thinking about using SQL in cloud, you should think about hyperscale as well, because it is just a database what you have been using so far. It is just a SQL Server database running in the cloud. It gives you same T-SQL capability, same query, same set of create table, select statement. Everything is just same. It is just running a database in the cloud. That's all it is. Um, so remember, we spoke about those problems, what we were trying to solve, and hyperscale solves those problems. First is, it is a scalable storage, right? And when it's a scalable storage, as I said, we have decoupled the compute and the storage, which means now we can independently scale up a database from 2V core to 80V core in a consistent time fashion, because we don't scale the compute, we don't scale the storage layer is separate. So we have solved the problem by decoupling these two storage. You see the point number 2, this is 100 terabyte. uh, Last week we announced the max size going to 128 terabyte. That's something which coming up in the subsequent slide, but this slide says 100 because this is what we released in the beginning, like when we released hyperscale, but now we have just changed it to 128. Um, and if you look at high performance pillar, we support read scale out using something called as a name replica, where you can add new compute layer to that. And when I say compute and page servers and other thing, it will come into the later picture. But compute is just a number of week or what you choose and a name you give it to it. So you provision a compute, give it a name, and it becomes a name replica for the same storage layer, right? Backups are quick in hyperscale. Again, they are taken by Microsoft. You need not worry about them, how they are taken, but you should know that you can restore them in the constant time. Database restore is faster because it's a snapshot level backup, not the traditional BAK, TRN, diff backups. This is a totally different technology to take a backup, which is a snapshot basically. It is a famous term, snapshot based backup, but it is what it is done in hyperscale. Um, Cost management pillar, Azure SQL Database Hyperscale Tier does not have a licensing cost. All we charge you is the compute and the storage. There's no license or IP cost which is at par with the other open source offering in the market. We have the serverless offering as well, which means you can provision a database between 2V core to 80V cores, and it will scale up automatically as the workload comes in, slows down when the workload goes away. So you pay for what you're using. You will not pay for provisioned storage. For example, if you say you have provisioned 80V core database, you have to pay for 80V core all the time. you use 1% or 2%, doesn't matter. You have to pay for 8 TB core. Whereas in serverless, you can define the min and max, and it will grow up and down automatically, and that way you can save a cost. There's a costing model difference in both. The cost and the price per vCore per second is different, because serverless bills you on per second basis, whereas provision is on hourly basis. So there is a different set of rules applied to the pricing, but for the workload which sleep for some time, and they're rapidly changing, for them serverless turns out to be good. Um, but it doesn't mean that if you have a provision, if you have a workload which is constant, you should move it to serverless. May not be, because serverless is effective on the situation where you have a workload going to a pause state for some time, which means there's no workload, so that you save the money. Otherwise, provision turns out to be better. Again, you have to evaluate the pros and cons of application usage and stuff like that. But this is what it is. And then we have redundancy at multiple levels in the last pillar. There are multiple layers there. Every layer has resiliency built in. We do provide financially backed SLA of 99.9% for availability, and yeah. So this all is there on the top. You see a link which says ak.ms/hs. That's the shortener over here which you see. If you go to this link in your browser, you can land to the Hyperscale documentation. All right. Just keep this in mind. The only cloud relation database you will need, use Hyperscale, no matter what is the size of the database. Very, very important message I want to put in your head, that Hyperscale is not for the large databases only. It can fit for any. It can fit for any database size. All right. Uh, Now I spoke a lot about Hyperscale. Okay, what it is actually like, and again, this is not something someone will ask in the interview. It is not something you have to mug up, you have to remember all the time, but this is for your information, that this is what happens behind the scene. So I'll use laser pointer over here. What you control as a customer is only this layer, like where my mouse is moving right now, and this layer is called as a compute layer, which is where you define how many vCores you need for a database. Let's say you provision a database, and by the way, this whole is this is just one database. If you see here over here, this is one database, and it has its own HA replica, and then you can create multiple named replicas of the primary compute. So for now, just keep it simple. Just don't assume about a name replica for now. Just focus on this area, right? So you have one primary compute, which is the read write copy of the database. If you want high availability, you can add more HA replicas, which will act as a hot standby. If you remember, if you have worked with on-prem, you remember always on technology. This is not always on, by the way, but you can think about secondary in always on is what is HA replica, right? So in case the primary goes down, HA replica becomes primary. So it gives you a hot failover capability. You can also use that HA replica as a readable copy, which means if you have a read-only workload, you can utilize those standby or HA replicas to connect and execute the queries, so that you're not wasting the power you have purchased for those HA replicas. Um, you can have up to 0 to 4 HA replica. We recommend to have at least one HA replica to gives you higher availability. But if you don't provision HA, it's fine in the dev test environment. Because provision, if in case the primary goes down, we will provision a primary replica again, but just take a little bit of time to spin up a compute and attach the storage over there, right? So that's the HA replica, right? So what you control from the portal or anywhere is a hyperscale tier with how many vCores you want, right? And how many HA replica you want. You will not control the size of the database, because that is seamless to you. You keep inserting data, we'll keep growing the database, right? Now what you see here is something called as paid server layer, right? Page server is a part of your database. So let's say you have a large database. Let's start with 10 gigs of database. When you provision a database, by default is minimum 10 gigs. You get a compute and you get one page server, which is just one over here, and it will keep on, keep on increasing the size till it reaches to 128 gigs. Once we cross 128, and again, this is just a theory, but we do pre-provisioning of the next page server based on the empty space. So it is not that once we are hit 128, we'll create a new page server. No, we will have a pre-provisioned page server, which we will add at some point of time, but it will be built only for the allocated space, right? So 128 GB will become one more page server and then one more page server. So now you see, because of this adding up new files as a page server, we are able to give you the capability of extending the database size automatically, right? So if you have database of 1 TB size, um, if you have database of 1 TB size, you will have 8 page servers, right? And yeah, so that's what it is. I see a hand raise from Jaita. Jaita, please go ahead.
Yeah, actually, the same thing I was going to ask means
Mhm,
how many page servers can be
mhm,
created? As you told, like it's not like in whenever it will cross 128 GB, a new page server will be created.
mhm.
So, how many will be created or provisioned from the very beginning?
By default, we create one page server. When you start a database, you compute whatever you say. Let's say 4 V core. This is the four V core compute, and we provision just one page server to begin with. That is, and you get a database size of 10 GB, right? For 10 GB, there's one page server, and you keep adding data. It becomes 20 GB, 30 GB, and it goes till 128. We will seamlessly add new page server, and again, this is not something you control. You just control the database size. You don't control the size. You just say I want. You insert the data, it will grow automatically, right? So and this page server will keep on growing till we hit 128 terabyte limit. So you can do the math. 1 TB has 8 page servers. So we start with one and keep on growing automatically for you. So when you run sys.database files in the database, you will see just one file in the beginning. Each file is one page server in this picture. So does that help, Jayita?
Yeah, thank
Okay.
you.
Cool. Okay. Thank you. All right. So this page server will keep on, we keep provisioning the page server based on the database growth. And if you look at the picture closely, every box here has one more box behind it. That is to show the two copies of a single page server. And that's what I was said in the beginning, resiliency, right? In case, cloud hardwares are commodity hardware. They can fail, anything can go wrong. You can never predict, everything will be perfect. So that's why we have to have a resilience in all the layers. So we have the inbuilt resilience in page server. In case one copy of page server goes down, other copy is already there to serve the compute, right? And then in the background, we will again spin one more page server somewhere else, because these all are, this is not a fixed machine where we have the data. It could be anywhere in the cloud, in the same data center, right? So that's the page server, which is a storage layer. Top was the compute layer, and then what you have here over here is something called as the storage. When I say storage, this is the real truth of the data. This is your actual data file, the MDF file, right? And where is the LDF file? LDF file is coming from the log service. So we destage it, and you have the log file also in the cloud storage. These all are, they contain the cache data. So when you do a commit of a data, we first write to the log service. This is your actual LDF file backed up, and unless it is written to the storage persistently, you will not get the commit confirmation, right? So commit guarantees that the data is there, because we have to follow the ACID properties and by the wall protocol. So we need to make sure that the data what you inserted, once you get the commit confirmation, data will be there, whatever happens in this whole system. If everything crashes and when everything comes up, your data will be there, right? So that's the guarantee which we give for the ACID property and the wall protocol. So this is your log service, right? Now what you see here is this is a single log service which is serving page server compute, which is the HA replica, and these named replicas. Now, just to named replicas are the endpoint which you create to read has a database called Microsoft DB, that you can say, hey, this name replica is actually copy of this. So everyone is talking to same page server layer here, right? Which means the actual data copy is just one, and you have multiple readers which are reading the data from these layers. And these all layers are independent of each other. So let's say you have a replica, primary replica of 4V core. You want to make it 8 TB core. What we'll do, we will spin up a new compute of 8 TB core, detach the page server, and attach the page server to 8 TB core compute, and we are done, right? We did not move any data. The page server is still the same. But if you really now if you think about the way it is done in on-prem world, if you have to have a new 8 TB core secondary replica, you will do a backup restore, right? Because the data has to move from one machine to other machine. Here, that layer is separate altogether. So we don't move the data. That's why the scaling operation is pretty fast in hyperscale. Right. So name replica helps you in defining the new endpoint to have a read-only copy of the data, and there are multiple advantages of name replica. First advantage is you can decide the number of vcore you want for the name replica independently, which means if you have a read workload which is very read heavy and it needs a lot of compute power, you may have a situation where you have primary replica as just 4 vcore, which is sufficient for your application to insert and do minor select. But name replica, which could be running larger reports, and you want to isolate it from the compute so that it is not interrupting with the workload, you can have a name replica of 8 TB cores, and that will have a more compute power to run those heavy duty queries without touching the primary, right? You can have a reverse situation as well, that you want primary to be super powerful and you want your HR team to have a copy of the data, like readable endpoint of the data, so that they can do a select, they can do some read activity, but you don't want to give them 8 TB cores. In that case, primary 8 TB core, name replica maybe 2 week or 4 week core, right? So you can have various use cases, and this becomes more interesting based on the customer situation. So name replica gives you capability to have an independent vcore as compared to the primary compute. And just to one point I will make here is HA replica is of the same compute power as the primary compute, which means if you have a primary 4 week core, HA will automatically be a 4 week core. We don't ask you. We just ask you how many HA replica you want, and then we will just provision for 4 week or each HA replica, right? So this is the overall architecture, which it gives you just a feeling about the decoupling. Scale up operations are separate. You need not worry about the growth of the data. We will manage the pacer automatically. So again, just a high level overview. We are not going dig deeper into the hyperscale architecture about when do we grow, what happens behind the scene, and this is good enough for anyone to appreciate and understand why it is so exciting to have hyperscale in the first place, right? It gives you a lot of capabilities and a lot of problems are solved with this architecture. With this, I will quickly show you how to create a hyperscale database, and I have a recorded video for that. So let's do that, right? Let me change the laser pointer back. Okay. So what you see right now, sorry. So what you see right now is the Azure portal, right? Azure portal is one way to create the database. And you can use T-SQL, you can use REST API, PowerShell, Azure CLI. There are multiple ways to interact with Azure, right? And all those interfaces allow you to create the database as well. You just need to provide the right set of parameters and the database is there for you to consume. So we are showing the portal way. So right now I am on my logical server, which I'm calling as my logical server, and I click on create database. Now over here, all I need to provide is the database name. So I'll say my new DB1, and then I will say I want a hyperscale database, right? Now, once I click on configure database, here I can choose various things. I can choose how many vCores I need. I can always change the configuration here uh, to to choose a different hardware generation, maybe from right now it's standard series, which is Gen 5 over here. And there are other series available, which is called as premium optimized or PRMS. And there is something called as premium memory optimized premium series, which is MOPRMS. These all have, different capabilities in terms of how much memory they support and stuff like that, how many vCore they support. So there are, you can choose whichever you want. This is the compute generation what you're choosing here, right? And then what you choose is the number of vCore, how many you need, right? So I can go from 2 vCore till 80 vCore, and then this is where I choose the number of HA replicas. Remember the picture which had HA replica? This is where you create HA replica, and right now it is one HA replica. It can go up to 4. If you put slider up to here, it becomes 4. If you put slider here, it becomes 80. Depends on the uh, hardware which you selected. It might become 128 as well, based on the hardware what you select, right? And then once that is done, you choose whether you want the database to be zone redundant. Now, just to few quick words about zone redundancy. Uh, you know, many regions have multiple data centers, which will be few miles apart. Now, these data center will have its own cooling, own power supply, own air conditioning, so that these two buildings are independent of each other. So, in case something goes wrong, it will be taking one data center down probably in case of some unforeseen situation. So if you choose multi-AZ for a database or zone redundancy for a database, we create two copy of the database, one in data center one in data center two in the same region, right? And this gives you more resiliency. And you don't charge anything. We don't charge anything extra for you. All you need to do is provision one HA replica, and rest all we will take care. We will make sure the database is there on two buildings or two data centers within the same region, and that gives you multi-AZ capability. So that's something which have been asked by many customers, to make sure that you never know what will happen to the building, right? You never know what will happen to the power supply. So to make sure that they are not interrupted, they are not database is not interrupted because of these unforeseen situation. We provide various features to overcome those problems. Uh, and then and then you choose whether you want the backup redundancy to be geo zone redundant or zone redundant. So how the backup copies are made available, that's something you choose. And then once that is done, that's it. You just say create, right? And once you say create, we will provision everything what I showed you on the bigger picture, right? That everything will come automatically for you. All you have selected is compute, how many vCore you need, how many HA replica you need. You haven't selected size, right? And that's the beauty. You don't worry about the size. Size is taken care of automatically, right? So, okay. That was that. And let's see. Yeah, yes, I played it again. Sorry. Okay. Any question about hyperscale so far? What we discussed. More than happy to uh, listen to questions and answer them. Okay. White audience. Nice. Um, Okay, now we'll touch base something about. Okay, let me ask you one thing before that. How many of you use SSMS? You can raise your hand. No need to unmute and talk. It's fine. Just quick show of hands. How many of you use SQL Server Management Studio? Okay, good. Almost everyone. Great. Okay, great. Thanks for being attentive. So, if you remember SSMS, it is a free tool, right? Um, how many of you? Okay, you can lower the hand. I will ask the next question. How many of you know that we have a dark mode in SSMS? Have you ever seen dark mode SSMS? Okay, people are raising hand. Good, nice. Okay, great. Okay, so I think not all the SSMS user know dark mode of SSMS. So we released a newer version of SSMS called SSMS 21. Um, you can download it. It is under preview, and that is built on top of Visual Studio, and that gives you immensely different capabilities. What can be done with SSMS, right? Um, with that SSMS, there is a co-pilot experience as well, right? Which means if you have used, I'm 100% sure all of you have used ChatGPT in one form or the other, right? You ask question and you get targeted answer rather than searching on search engines and looking at each link which will give me the right answer. ChatGPT has changed the way we troubleshoot a problem. Copilot is there in SSMS as well, right? SSMS has a Copilot in the newer version of SSMS. So if you have not tried yet, try the latest SSMS preview version. It has new capabilities of Copilot. You can ask question about, hey, what is the query to change? What is the query to change the compatibility level? And it will give you query, alter database name, set compatibility level is equal to 160, and you can interactively get the queries out from that. So pretty exciting thing there. But what I'm going to show you today is something from the portal perspective, right? This is not a SSMS session, but since this is hot of the press, very recent announcement which was made, I just want to make sure that you're aware of the newer SSMS capabilities. And if any feedback is there, you want to see more, please let us know. More than happy to hear that. There are few hands are still raised. I'm assuming there are no questions. Okay, if there are questions, please go ahead. There are two hand raised, one from Shashi Reddy, one from Manish. Okay, Manish has lowered the hand. Okay, which means they were left over. Okay, good. So what I will show you now is capabilities of Copilot in Azure SQL Database, right? Not SSMS, Azure SQL Database. So let's move on. So there are few capabilities which are there in the portal in Azure SQL Copilot, we call it as, right? And you can go to the link ak.ms/SQL Copilot to learn more about it. Now you can ask the natural language question to the Copilot and say, give me a query to do this from the database, and it will go to the database, look at the schema, and give you the actual query, what is useful. You can ask question from Copilot. Hey, Copilot, what's wrong with my database? Why it is slow? And then Copilot can go and look at the database query store and say, looks like you have a missing index. Looks like you have a high CPU situation. Look, it can look at the historical data as well. And so there are multiple capabilities which are built into the Azure SQL portal, and I'm going to just demonstrate few of them right now. Okay, so this is the first capability. What you will see here, right? So this is the database which we have on the right hand side. We call it a sidecar. You will see a Copilot experience there, right? So we can ask the question from the Copilot. Hey, Copilot, what are the things you can do for me? And then it will look at its own knowledge base and give you the things what it can do. And if you see it can do troubleshooting diagnostics, optimization of performance. I think those are interesting things. So probably as a next part, what we could do, we can ask more questions from the Copilot and see what it can do for us. So let's ask the next question from the Copilot. Okay, let's go next. Next slide. Okay, again. Okay, so now I'm going to ask from Copilot. Like it is in the context of database, right? So I say, hey Copilot, my database is slow. What it will do, it will go in the database context and it will run the query based on your connection, and then it will go ahead and see the query store and say, looks like you have a high CPU situation, right? And if you see, it has said CPU was more than 80% for 14 minutes in past 1 hour. Your maximum CPU has went up to 98%, right? Which are the good indicators of someone who doesn't know SQL, right? But if you're expert in SQL, you are a DBA, you know how to solve this problem, but it will take a while for you as well to identify and get the queries handy, stuff like that. So now if we continue asking this question and say what else you can do, if you see it has identified the query, and then next question would be, okay, I you told me the query, what can I do with this query, right? That will be the next question. So it will say, and it will right away what the problem is, right? So if you like that, you can keep asking question, how can I can optimize a high CPU usage? So it will again go back and say, this is the query I identify, which is creating consuming a lot of CPU, and looks like there's a missing index, right? So it says I have a missing index of this table, and it gives you the query on your face that this is the index you create, and that is going to solve this query problem, right? That's amazing, right? If you are a seasoned DBA, you will have some script on your back pocket all the time. You'll have a folder on your laptop which will have all the queries which you run. But again, opening the folder and the query and asking question to Copilot, both are different experiences, right? So I just love this experience because it can tell you what the problem was. It can tell you the solution of the problem along with the how to implement it, right? Which is great. So I think this is one capability in Azure SQL DB Copilot experience, right? So this was first experience, right? Uh, Next thing, what the Copilot can do is give you the conversion of a natural language query. How much time we have? Yeah, we have time. Give a natural language query convert to a SQL query. So, and this is the demonstration for that. So this is called as inline Copilot, right? So you just go to the Copilot, ask a question, and question is find the hierarchy of the product category at any level, and that's the natural language what you use, right, to talk to a Copilot. And then Copilot is going to go, and you have to tell Copilot how many tables should I look at. Do you want me to look at all the tables or selected tables, because that will narrow down the scope of work for Copilot. So I will say, okay, select all the tables, give me the query now. So now it is going to look at the schema of the table, column name, table name, and you can't have a column name called ABC and table name called T1 and ask a question like this. It has to be a meaningful name. It should be so the database schema should be a humanly or computerly understandable schema, right? If you do that, you can take advantage of Copilot, and it will give you the reason why I did write this query. It will also give you the query. So if you see, it said I am going to use CTE because there's a hierarchy there, and it gives you a pretty interesting query. And I'm sure for seasoned DBA as well, it takes little time to write a CTE query. And I make a lot of mistake while writing CTE query, and especially the recursive queries, right? So if you see, it has given the query, we executed it, and it gave us the right side result about the level, what level they are on, and if you see level 0, level 1, which is like a hierarchy, right? Hierarchy has been built by this. So interesting usage of Copilot. You can use it to convert natural language to SQL, right? Now this what I asked from Copilot, if you really see, this is the most common interview questions. Like one of the interview question is, okay, find second top salary from the list of salaries of the employee, who is getting the second or third top salary, right? So I think those are the questions you can ask from Copilot just for fun, and I'm sure it is going to give you the right answer. You can't hire; it is already hired, by the way. So yeah, all right. So I think that was the Copilot experience, and you can do multiple things there, right? Okay. Any question before I cover the next new set of enhancement what we have done? Yeah, Jayata, go ahead.
Copilot queries or the result we are getting from Copilot,
Mhm.
can we rely always?
Okay, I think it's very common question to hear that is the query made by Copilot reliable? Most of the time it is, but you have to still use your little knowledge about SQL to make sure that the data set is coming proper, because Copilot can make mistakes. We all know that. ChatGPT can make mistakes. We all know that. So there is a human intervention required to make sure the decision made by Copilot and the query is correct. Most of the time it is correct, but again, we have to validate for sure. Yes. And even if you see when you ask in SSMS Copilot, if you ask a question and say, "Give me this query," it will always give you a word of caution in the comment section. Hey, validate the query before you execute it, because you never know what can go wrong with the Copilot. It's just a machine, right? So yeah, it is mostly reliable, but human intervention is required for sure at the end. All right.
Okay.
Um, okay. Thanks, Cheta. So I think next set of things are something new. Not all things are new, but there are things which are there in the sorry uh, in Azure SQL Database. JSON data type regex is something very interesting, which is built by one of my peer PM in my team. Regex is like it's a search. It's like it's doing a search using the regular expressions, which is called as regex. It is under the private preview, and there are multiple improvement like Unicode string with the. There's a new pipe operator which come up. Uni str is a new keyword which we added, and the heart of the press thing is the vector data type. uh, I'm sure by this time many of you have heard of something called as vector, and vector data. In SQL, we support vector and Azure SQL DB. What we started supporting recently is the native vector data type. So you remember you have a character data type, where binary data type, image data type. Same way now you have a data type called vector, which can store vector data, right? Like an integer float, and which can store number data. Vector data type can store vector data, and then it is integrated with various new developer friendly things like LangChain, EF Core, semantic kernel, logic apps. Everything is integrated. REST API, you can invoke REST API from SQL using there's a function called invoke REST endpoint. And we have Azure Function Binding and Data API Builder as well. These all, if you want to learn more, there's a link at the bottom, ak.ms Azure SQL Dev blog. There's a we keep writing blog about the new development experience enhancement, what we do. Right? So this is something which I've been asked to put, because something new which will be loved by the developers, because it is. And these all are, by the way, these all are used a lot in AI development, right? You use a lot of vectors to do AI data development. So pretty exciting thing have come up there. All right. New things which have come to the hyperscale, which I gave a hint in the beginning. First is the increased capacity. Earlier we used to support 100 terabyte. Now we have increased that to 128 terabyte, which is a great thing. Many customers said 100 is not sufficient. We want more, so we have come with 128. In future, we don't know yet, but it depends on feedback and usage. We might go beyond, but as of now, 128 became because it was asked by customers, and we listen to the feedback very carefully and do what it takes. That is the first enhancement. Second enhancement, what we have done is uh, log generation rate improvement. Log generation rate in hyperscale is 100 Mbps, right? 100 megabit per second. Now, instead of 100, and 100 Mbps is not good enough for few workload who do the bulk loading of the data. They ingest a lot of data at very rapid rate, and they were peaking this 100 Mbps limit, and they asked for more. So we have announced recently 150 Mbps limit, which is 1.5 times than what we have today. We have increased it. In case there's an interest, and if you have any workload which is being throttled at 100 Mbps, do let us know. Ping me. If you go to the link below, HS enhancements, ak.ms link, that will have a link to sign up for the limited preview. So it is not public yet, as in public, as in it is not on by default. if you let us know that, hey, we have a use case we want to onboard this feature for our testing, we can enable it. We can allow list your subscription or the database, and you can enjoy 150 Mbps, no extra cost. But we need to first evaluate this, right? So it is under the limited preview as of now. Now in action, if you really see 128 terabyte space, this is one of the database which we created, and this is from the this video is taken from the PAS summit, what happened recently. And if you see maximum storage, what you see here is 128 terabyte, right? That is what we support now. And just one thing I should add is this is available on the premium series hardware, not on the standard series hardware, right? Now, has it come to 128 all of a sudden? No, we have been populating the data over a period of time. And if you see, every, and that's how the pages are being added, right? You keep growing. If you hit the limit, we increase the size automatically for you. So you do not worry about that thing, right? So yeah, that's the quick database which is showing you the capability of going up to 128 terabyte storage, right? Which is great. Um, and this is something which we recently published. I think we have 7 minutes to go. This is something which we recently published where we uh, where third party got principal technologies performed a comparison of the workload between two Amazon Aurora in AWS platform, and in Azure they selected Hyperscale, and they did the comparison of the this workload. And they found that it is much financially performance beneficial to run that workload in Hyperscale. So this is the public case study which is there on the link which is there. If you just search for Azure DB Hyperscale benchmark, you should be able to get it. So this is a third party study. They have compared HS Hyperscale and the PostgreSQL flavor of Amazon Aurora, and this it turns out that AWS is not like Azure performs much better even for less or more users, doesn't matter. So that's the graph on the right hand side. Okay, so one more thing which we announced, I think if you now look at this picture, I just inverted a little bit, but still the same picture. What you see here is the primary replica, it's HA replica, log service, and the page server hit sitting here right now, right? Earlier in the picture they were down, and there's a reason why I put them here, which you'll understand in few seconds. Now, if you look at the HA replica, let's say you have a workload running, right? Um, Whenever you have a workload running, let's talk about on-prem for a second, right? There could be a situation in on-premise where everything is in cache, right? Everything is in the buffer pool. When the machine restarts or the SQL restarts, uh, your whole cache is gone, right? Nothing is there in the cache. It has to be warmed up again. So you have to run the queries to get the data into the cache first, and from there you can read it. It may not be a few applications do see this restart impact. And again, it totally depends on the workload. If your workload is not sensitive to such hiccups, it's okay, good. Otherwise, there could be few applications which will experience performance issues when there's a restart of a service, restart of the SQL service, database, failover, whatever, right? And the reason of that is it is depending on the data in the memory, correct? Now imagine the situation here, right? You have a primary replica and we have HA replica. You are running all the queries on primary, be it select or whatever. They are running on the primary, and once because of some reason the primary has to go down, HA replica has to become a primary, and once HA becomes primary, the data has to be read again from the page servers, right? Which means whatever, and this is the network call, by the way, right? That's the hyperscale architecture. It's a network call to read the page from the page servers. It is quick, by the way, but looking at some workload, they start reading a lot of data on restart because the workload is like that, right? Now, which means it might take a while to warm up the cache here, right? which means you may have a performance impact for initial few seconds to minute when the failover happens from primary to HA replica, which is okay for some workload, not for many. Now the solution of this problem, what we came up, which is what we have released as a preview, is we call it as a continuous priming feature, right? Where from the compute, we send the active page list to the page servers. Hey, these are the hot pages. And these hot page list is sent to the HA replica, which means the active pages which are here are primed or available in the memory of the HA replica as well. Now the advantage of that is in case let me put my laser pointer for better visibility. In case my primary has to go down and HA replica has to become primary, we have the active hot pages in the cache already, which means the warm up or the impact to the application on restart would be much lesser than it would have been there without this feature. And to show this, I have we have run a workload to show how it looks like, right? So at this point of time, there was a restart of the primary and secondary became primary, and then application was reading the data from the primary. And if you see, without the continuous priming, it took around 4 minutes or so to get the application back to the normal behavior, right? Um, Now, again, this is the workload which is being impacted. Not every workload will have the same problem. If the workload is sensitive to the cached data, then this problem might be there. Now, this is without the priming, and you see that there's a lot of page avalanche happening because we have to read the data from the page server. With the continuous priming, that time has become less than a minute because the reason is the pages were there already in the buffer in the cache of the HA replica, right? So this is a super cool enhancement. Again, improved based on the customer feedback, pain points. So we are taking under feedback and improving the services as we go along. So I think this all was about the hyperscale feature. Now I will end up with this slide where I can invite you to take advantage of Azure SQL DB free offer. We provide Azure SQL Database free of charge for the lifetime, and you get 100,000 week or second per month, right? And once this is exhausted, you have other option to either purchase the database or let it be paused state, and I will start learning again. So and it is okay for you to learn using Azure SQL DB, right? Customer are using production as well. This is a serverless database, which means it will sleep automatically once it is not in use. So I think very good offer in case you want to try it. Once you create a subscription, you can get this free database for your lifetime with this limitation what I just mentioned. So you can go to the link SQL FreeDB offer. That will give you more information about what this enhancement is all about. So to take a screenshot, go to the link if you want SQL free offer, and then you should be able to learn more about this. And to close with, I think we are just on time. Uh, Takeaways for today is, Hyperscale is the cloud native database for all the workloads, not just small databases. Hyperscale grows as your workload grows, which means there's a scalability aspect there, and it is the price performance leading offering from Hyperscale. If you go with serverless, elastic pool, and other, like there are multiple things available with Hyperscale, like serverless elastic pool, which we can discuss some other time. But there are added advantage or additional features which you can use based on the workload to save more cost. And this is the last slide from my side. Take a screenshot. It has many ak.ms link which I have covered in the past. So take a screenshot, save it whenever you have time, go through them, learn more about Azure SQL Database. And with this, I think I'm done. I'm just on time. We started 2 minutes late. I'm ending 2 minutes late. Sorry for that, but I think it is what it is. Thank you very much for your time. open for questions. Yeah, Manish, go ahead.
Hi, Balmukund. Thank you so much for the insightful session.
Sure.
I have two questions, Balmukund.
Mm-hmm.
The one is regarding the Copilot.
Mm-hmm.
So, when we use the Copilot in SSMS, like the upcoming that you mentioned, right, 2020, upcoming 21 version of the
Yes,
SSMS.
yes, correct.
So, does that Copilot use the data for its own training purpose
No,
as well?
it does not.
No,
It does not.
never.
It does not.
Okay.
Never, never.
Okay.
That's the
Like in
promise.
ChatGPT, there are some in
No.
ChatGPT there are certain paid version and certain free
Yeah,
version. So like
yeah.
I was asking. Okay, great. Thanks.
SSMS
Thank you.
does not. 200%.
Okay, great.
Yeah.
Okay, great. And the second one is today morning only I got the dark theme what is it like the dark theme of SSMS, and I
Uh-huh.
was just playing for a few minutes and it was very nice to have that feature.
Mm.
However, when I tried to do that execution plan, that was not coming in.
Dark mode.
That
Yeah,
was not
yeah.
going in a dark version. So is that
Correct. Correct.
something which will expect in
Yeah.
future, or that's by design something?
Yeah, so if you really see the announcement blog for SSMS, not
Okay,
all the places have become dark yet.
I
So
see,
we
I
are
see.
we are
I
still,
missed it
so
probably.
so yeah, so the query editor has become dark, object explorer has become dark, not every places,
Yes,
but yeah. So if you find some places which is not there, you can ask a question or just send an
okay,
email to me and I will get the answer to you. You have my email address, B Lakhani.
exactly.
Ping me on
Yeah,
LinkedIn. I think you are the one who
I do
who,
have
who
it.
messaged me, right? You just
Yeah,
ping me,
I do.
send an email. I will get this double checked from the PM who works
Mhm.
on SSMS.
Definitely.
My honest answer is I think it will
Mhm.
come, but again,
Yeah,
I will get the authoritative answer to you once you send an email to me.
I understand. Thank you
Yeah.
so much.
Okay. Sure, Manish. Thank you.
Thank you.
Deepthi, go ahead. Your hand is raised.
Yeah, hi Balu sir, how are you?
Hi. Good. How are
I
you?
yeah, I'm good, good. Sir, actually, I have some doubt related to the not related to Azure, but
Mm-hmm.
it is related to the on-premises where we have one of our e-commerce application
Sure.
is actually facing a challenge. So,
Mm-hmm.
what is the current scenario? Is like 40 to 50 users are currently using the application,
Mm-hmm.
and they are resulting in some deadlock.
Okay.
But we have verified it from the perspective of database optimization, deadlocks, and everything, indexing, everything was done. But
Mm-hmm.
later, to some extent, it has got resolved. But the kind of challenge that we are facing is like if the application user count is surpassing 200 on the production server, so again, it
Mm-hmm.
may come to a challenge.
Yeah.
So for that, like what we suggested is like creating a load balancer in the web server. But
Mm-hmm.
one of my other architect friend also suggested me
Mm-hmm.
either to go with a load balancer at the web server, and it is better to create a SQL Server instance
Mm-hmm.
and to have some replica over there. But how far like creating that will help us, or does we have any other alternative solution for it? Because since because of the cost criteria
Mm-hmm.
for the account, they are not actually moving to cloud from on premises to cloud. So
Mm-hmm.
here like could you please suggest like is kind of like any
Sure.
other way that we can address this?
Yeah. I think I will start from the very first point is that the deadlocks are appear because of the conflicting locks from
Mhm,
the application, and it
mhm,
is it is always between two sessions, right?
mhm,
Um, if it becomes 100 sessions and causing deadlock, which means it is definitely a there's some long running query which is taking conflicting locks, right?
mhm,
The easiest way to solve deadlock is separate read with writes, right? If someone is writing the data, let them only write. Don't let them read. And read should be separate because
mhm,
the lock between the read and writes are conflicting, right? When you have to
mhm,
read the data, you will wait for write to finish. So if you remember the simple demo of creating a deadlock is select insert and insert like two different session doing reverse locking. The easy way to solve would be to separate the read and writes by creating a replica, maybe always on replica, or whatever method you want to use. that will that will be a decision you have to make because there will be a lag of the data on the secondary. So if your application is sensitive to the reading of the data at the exact same second or millisecond when inserted, read replica situation may not work. In that case, we have to go with the traditional approach of analyzing that deadlock graph, And deadlock typically happens, based on experience. Either it is the conflicting log taken by the application because they are doing the things in the different order at two places, or a missing index. Uh, uh, Once you analyze the deadlock graph to identify what exactly is the resource, which is where we are causing the deadlock, removing that resource from the equation generally helps. So I think if you cannot do the first option of having a read separate than write,
Mhm.
then the next option is to look at the deadlock graph,
Mhm.
identify the conflicting queries, and see what has done before that. Just by graph, you may not be able to get the whole picture. What you need, if it is on-prem, a profiler along with the deadlock graph, right? Because you need to backtrack the event, what has done by the session ID. Let's say there's a deadlock between 50 and 51. You have to see what 50 has done before hitting the deadlock situation, which means you need a profiler or the series of queries which have come from 50 and 51, because that is what will tell you what caused the deadlock. From the graph, all you can tell is this is the resource, these are the two session IDs which got deadlock, and this was the resource, this is the query running, but it tells you the currently running query. It doesn't tell you what it has done prior. So in my experience, profiler and deadlock graph together can give you what is causing it, and that can give you more ways to solve the problem than looking at just a deadlock graph.
But I just wanted to understand if we have an it seems even though we have indexed and done
Mhm,
all the kind of like where exactly for the resource we are getting
mhm,
log on that and all we
mhm,
have did a performance on that.
mhm,
But
mhm,
my query is we have something called uh, always on group availability, but
mhm, mhm, mhm.
whether this will be the read and write will happen synchronous or asynchronous, as you said, when it comes to the primary road, it will write on the primary and then it
Yes,
will acknowledge whether no whether the
correct,
secondary
correct,
transaction has committed by the secondary or not.
correct, correct,
So,
correct.
but do we have a synchronous update that happens in SQL Server on-prem?
You cannot guarantee. You cannot guarantee. So it may so happen that you inserted a row on primary. Let's say the table T1, you inserted a row,
Mm-hmm.
right? If the redo is lagging on secondary because of any reason, because of high CPU
Mm-hmm.
condition, redo block situation, you may not see that row which you inserted maybe for few milliseconds, few seconds, few hours,
Mm-hmm.
depends on how busy the redo on the secondary is. If the redo is not
Mm-hmm.
able to proceed on secondary, you will not get the data at all, right? So that's why I said,
Mm-hmm.
if your application is sensitive to data, in that case, read from the primary. There's no other go, because
Mm-hmm.
any secondary will always have some lag, millisecond lag or a second or a minute lag, depends on the load, but there will be a lag for sure. So if that is a situation, you have to move the workload to primary. Like you should read from the primary only, and then the only option left is to solve the deadlock problem. By the way, uh, your application should have a retry logic, right? Because wherever there's a deadlock, the message says retry, right?
Mm-hmm.
You are a victim of the deadlock, and you have to retry your transaction. So other way to solve this problem is have a retry mechanism. Do not show it to user that hey, you got deadlocked. If there's a 1222 error within the code, you handle the error 1222 or 1204. I don't remember the error number. If that error comes, retry the transaction, and most of the time that succeeds, right? So
Mm-hmm.
rather
Got
than
it.
solving the deadlock completely, which probably sometimes you can't solve it because you already
Yeah,
optimized the
because
performance, queries are
yeah.
optimized. It's just the application, the way the queries are being run in the application. You can't control
Mhm.
that. So in that
Correct.
case, application has team has to uh, build a retry mechanism that hey, if there is a deadlock error from the application, do not throw to the client, retry the transaction, and it will succeed next time. So I think that's something which app team also has to contribute there, not
Okay.
just
Do
the
we need to put any
database.
kind of like a connection pooling, do we need to make any threshold limits, like this
Connection
many users only,
pooling will not
like
help.
maximum users who will use the application? Because
Uh, yeah,
we
the
may
advantage.
experience it can
Yeah, yeah.
surpass more than 200.
Yeah, I think pooling helps because pooling saves you on making a new connection, but
Mhm.
pooling will may not help in a deadlock situation because
Okay, I got
de
it.
Deadlock is more of a transaction happening within SQL. It is coming via pooled connection or a new connection, doesn't matter. It is all about the sequencing of the object access, which causes the deadlock. So pooling is not something which might help in my opinion. Retry is something which should help, which should be done from the application side, and tuning is what to be done from the DBA side.
Definitely,
So
definitely.
yeah. Okay.
Yeah. Thanks a lot, sir.
Good.
Thank you so
Sure.
much.
Thank you. Yeah. All right. Any more questions? And by the way, those who do not know, I run Azure SQL Bangalore user group in Bangalore. We are having a next event on 30th of November in Microsoft Bangalore Funds office in Belandur. So in case you want to meet me in person, feel free to drop by. It is a free event. Register on Meetup. Just search for, I posted on my LinkedIn as well. So have a look there if you want to meet, have more detailed discussion about something. More than happy to talk. 30th November, Saturday. I think with this, if there are no more questions, we can wrap up. Saranya, any
Sure,
closing
sure.
words?
Yeah, thank you. Thanks a lot, Balmukund. Thank you for the
Sure,
session. It is
sure.
really informative. And I'm sure we'll definitely catch up in the following sessions. And
Yeah,
thank you for about the session on November 30. I hope many of us will be able to make it to the
yeah,
session that day as well.
sure, sure.
Thank you all for joining
Okay.
the webinar. Yeah.
Thank you very
Thank
much.
you. Thank you, team.
Thank you. Bye bye.
Thank you. Bye.